Thanks for attending. Hopefully a few of the people in the audience were in Zach's presentation just before. There's going to be a little bit of overlap in explaining who I am and what we do at Riot, but there's a bit of building on top of what Zach did, so if you didn't catch that, check it out when the videos are available. But I'm going to be talking today about implementing a quality cloud CI system using Horde. And if that title is a little confusing, we're going to go into some of the detail of that a little bit later. So, is this working? Oh, cool, it's not working. Is it off? Yes. Sweet. I'm Jacob, Senior Software Engineer at Riot Games in the Sydney hub. And hopefully, hello, welcome audience. Hopefully you are at least a little bit interested in build systems. Maybe you've not done too much in the build realm, but obviously you need to compile your editor and cook your games to get your awesome experiences out the door. And so hopefully, if that seemed like a chore before, by the end of this talk, you may be a bit more excited about it and you have a bit more interest in getting involved in build in general. So I'm going to go over sort of really 4 rough areas today. Going to tell you a little bit about what we do in the Unreal ecosystem team, adding on top of what Zach does, which is a slightly different area. We're going to look at what builds at Riot for Unreal used to be like in the sort of preceding last year. Have a bit of motivation for getting some change in there, why we're talking about implementing a new system, and then look at what it looks like to actually work with Horde and see how things have changed. And then finally, not everything's roses. We'll have some challenges we're still trying to work through, so I'm going to illustrate some of that stuff and give you an insight on what's happening at Riot. So, introduction to the situation. Welcome to the Unreal ecosystem team. You've seen this unicorn logo already, maybe, but yeah, so I work in the Unreal ecosystem team. We own a product called Core SDK, which is Riot's flavor of the Unreal Engine, and what that means is we ship a bunch of useful integrations, login systems, sensible defaults. If you want to kickstart your project, you're going to be getting Core SDK. You're going to be able to one-click deploy into a nice game template, and it's going to have a few things ready to go, so you're not starting from scratch. In addition to this, we have a lot of build tools and infrastructure tools. So that's maybe a little mysterious at this point. What are build tools and what are infrastructure tools? So what we are helping our teams get set up with is build scripts. So how do we ensure that you can compile for Xbox? How do you ensure you can also compile and cook for PlayStation? But also we do that on cloud infrastructure, so you don't need to use your local PC. So I want to go through a couple of side quests to begin with, so we can get some definitions done, so we can talk about everything in the same sort of common language. So CI/CD, that's the main topic that we're talking about here. Continuous integration, continuous deployment, delivery, depends on your flavor. So continuous integration is really what it says on the slide here. If you're going to make a change in your code base, we're using version control. When I make that change and I assume that everything's good and I commit that to main, I'm distributing that to everyone on the team. We want to kick off processes when that change goes through, such as tests, automation in general, or even stuff like running through your code and making sure that you've got everything in the right format that we've agreed on in the team. Once you've done that, you've compiled some stuff, you've got some binaries, they're being distributed out, you actually need to deploy that. So the deployment stage of that is making sure that everyone else in your team can access the things that were just built in the CI step. We can take that another step further, and if we say, this is a blessed build, we're going to deploy that all the way out to players or playtesters. Depending on how risky you feel, you could put it right out into the wild. So CI/CD is the holistic build and automation process that starts with the developer's code change at their computer and ends up with a playable game, a useful tool that's deployed to someone else somewhere, could be in the whole world. Talking about the cloud. This is something I think that everyone refers to as the cloud. What does it mean, really? it's mostly just computers somewhere else. We pay a company to provide us with servers somewhere, and we run our tasks on those servers. At Riot, we're a partner of AWS, and that's been largely my experience over the last sort of 8 years is working with AWS. So AWS provides us with computers, storage for loose files, but also databases and all sorts of useful tools. Riot doesn't like to own computers that sit under desks that aren't for people to develop on. We don't want to own a bunch of hardware that becomes obsolete, ages out, and then just becomes a big pile of scrap metal. We want to keep things in the cloud so that we're flexible. We can define what compute we need as we need it, and we try to use AWS in a controlled way. If you want to launch a server in AWS, if you go into the website and you want to click things through, first you have to fill out this page, then this page, then this page, and then this page, and I've gone cross-eyed. The illustrative point here is that using the tools as presented is not always the best option. If I want to launch one server for one specific task, maybe this isn't too bad, but what if I want to launch a fleet of servers, or if I want to launch the entire Valorant playable server system, which is worldwide? I can't do that by clicking these buttons over and over and over again. It's going to be impossible the second time to even remember what I did the first time. So we use tooling for this, and there's two really important concepts which are sort of backbone for what I think about when we're talking about infrastructure, and that is infrastructure as code and configuration as code. So sort of do what they say on the tin, but they're a bit subtle, and there's a very important point here, which is really that we want to define whatever we want to make as code. So infrastructure as code, we're setting up a server. It means that we can add that configuration into a version controlled repository, and it means that I can see that all laid out in front of me. I don't have to use a website. I don't need to remember the things that I put into a text box. If I need to make another server, I can copy and paste it, or maybe run that infrastructure as code again. You can use for loops, you can use things like that. Configuration as code is really the same concept, except instead of code for deploying infrastructure, like new servers, it's the actual application configuration that might be running on that server as well, but it's really the same thing. When we have these things in code, we can't, just having them in code isn't enough. We need tooling to be able to run that configuration and then make something happen. To interact with AWS, we use a tool called Terraform. There are a few different options out there, but essentially what this tool is going to do is it's going to take our configuration. It's going to ask AWS, hey, did you actually deploy that server? What's the state of things in the cloud currently? It's going to compute the difference between what I've asked for when I'm setting up my Valorant servers and what's actually there, and it's only going to provision me those resources that are the difference. This is really important. It's idempotency. It's really important in the cloud because unlike other application code, when you deploy AWS servers, there's a physical cost associated with it, and a physical machine is being allocated to you. There have been circumstances where we've over-deployed, and AWS are like, no, we've run out of computers. There's literally, we can't deploy any more servers, you've taken them all. So, side quests complete here. What does the Unreal ecosystem build an automation pod do? We provide build tools, configuration as code, infrastructure as code, all of this good stuff for a new game team to get off the ground. They're able to spin up any of the resources they need in the easiest configuration possible with sensible defaults and go from an incubator project all the way to a fully deployed live game. Cool. So, probably blazing through this, so I need to calm down and talk slower. But what was the previous state of build like? About a year ago at Riot. This is kind of an overview of what a standard build for an in-development game with a good amount of content looked like approximately a year ago. Builds took about 5 hours. That's almost unworkable, right? Because if you think about how many hours there are in the day, and a build takes 5 hours, that means you're only getting 4 to 6 builds sort of for the whole day. If you need to get changes shipped quickly, you need to do a hotfix, you need an emergency patch, you're suddenly running into a lot of issues which are just impossible to get through. And sort of additionally, there's a build history problem. We didn't have very much opportunity to understand exactly what was happening in historical jobs, look at trends and things like that, because our telemetry was largely ephemeral, which was kind of features of the build system. We had more challenges than that, in fact, so builds are long. Part of the reason for that is that in the old system, parallelization of the builds was really difficult. The build system was independent of Unreal, which meant that in order to add in parallelization, you had to know the build system. And that would be fragile, and if you needed to change your build at all, then the whole parallelization step would need to change as well. As I mentioned, the build system builds on top of Unreal, was independent of Unreal Engine itself, which means that in order to update those jobs, you would need to have specific knowledge of the build system itself, which meant that you can't run your build jobs locally. What's happening in the cloud in the old system is completely unique. There's almost no way of replicating that locally without a lot of work. So if something's gone wrong, you can't just fix it if you happen to spot it. You'll need to go ask the build team. You're going to need to get their help. They're probably really busy putting out another fire, and you can't even reproduce it locally. We also had some missing features. We use Perforce as our main version control, and with Perforce you can shelve some changes, stash them away for later, or share them with other people. We didn't have any capability of running a build with those shelved changes, which meant that in order to make sure something got built properly, you would have to submit that to main. You can see that that's very brittle. If you had any mistakes, which are easy to do, that could break the build for everybody, and if you've only got 4 to 6 builds happening per day, you've just wasted another 5 hours of everybody's in your team's time waiting for you to get the fix in and unblocking everyone. And because of this situation, no one cared about build. Build was the necessary evil. You just, all right, I'll submit my changes and I'll go home for the day. I'm not going to worry about that. Maybe it will be built when I get home. People wanted to have faster builds, but they didn't know how to approach it. People wanted better builds, more capabilities, but barrier to entry was just too high. There were some successes for the previous system as well, though. It wasn't all bad, and we had a system that was easily set up with low configuration. It meant that a team starting a new project with Core SDK could automatically get all of their systems set up very easily, but what actually was deployed was not that great. And although there were separations between the knowledge required for the build system, we were really just orchestrating and running build graph under the covers. It took a while to dig down to that layer, but we are integrating with Unreal Engine tooling, makes it simpler. So we thought that we had a few ideas of what we wanted from a build system and what the important things were for distributing build to many project teams, many game teams. And we thought we could improve on what we had. So first thing we think is that we need initial setup to be pretty low effort, and we want sensible defaults. So when we're spinning up a small project team, this could just be a proof of concept or something. It doesn't necessarily have to be an entire game that Riot wants to work on. We want to keep that low barrier to entry so that that team can work on their specific thing that they're trying to validate or kick off an entirely new game. We want any changes that we make to the build system to actually help us overcome challenges that we're facing. And that can be within the build system itself or within game teams who are trying to do certain things. If we make any changes, we don't want to just give it a new coat of paint. We've changed from green to red, and therefore it's better. That's what we want to avoid. We have pretty low tolerance for integrating new tooling just for the sake of integrating new tooling. So some of the options that might be around for us would require us to maybe move source control or something extreme like that. And we have a lot of tools already. We don't want to have to reskill, retrain on other tools just because of a build system. We want to be able to version everything, going back to our principles of infrastructure as code and configuration as code. And we don't want ClickOps, like Austin Powers showed us before. So we found ourselves at an inflection point. We could continue enhancing the previous build system. I'm sure we can improve it. There was a lot of ways to go. Or we can look for something else that maybe meets our criteria and the recipe for success a little bit more closely. So, unsurprisingly, from the title of the talk, to the shock of nobody, we went with Horde. This is my super low-res picture of Horde that I clipped from the web UI because I couldn't find a better logo for it, but I love it, it's cute. So I've said Horde a couple of times now. What is it? What does it even mean? So let's have a quick look at Horde, and we'll show you some of the features of it in a very high-level way and kind of explain that it's not actually that much of a mystery. This is our core SDK front end for Horde. So if you log onto Horde in our project, this is what you see, a magnificent Comic Sans unicorn. And does the laser work? Yeah, awesome. So these are some of our Perforce streams. So Horde is intimately tied into Perforce, and we've configured it so that we can look at different jobs and see them per stream. These are, at the time of I got this screenshot, these are like our main development streams. We have some release streams as well, because we do versioned releases of the product. And we have a few tools that we build in separate streams as well to keep them nice and isolated. So if we click into Dev UE5, which is our main development stream, this is kind of the overview. So this is just a timeline view of different jobs that we're running. And the green is good, of course, which means all the stages of the build are working successfully. But you can see down here this nightly clean build. Hopefully you guys can read that. This is a nightly clean build. Something's going wrong with Android. And looks like we couldn't deploy Android for some reason. But the subsequent builds after that all worked, so maybe it was a transient thing. We'll pass that to Zach to fix the tests. So when we click into a build job itself, I'm not going to show you all the steps there because it's kind of just tedious. It lists out every single step that you want, that has been run. This is an overview of the entire build job itself. So this is the graph view, because everything is run through build graph. Shows the graph view and shows the parallelization. It's a hard word to say. And also how long our agents were waiting to begin their tasks. So at the beginning, we sort of have the compile editor steps, because that's the dependency for a lot of stuff. Then we'll compile some targets. And towards the end is where we cook for each one of those targets. And the really nice thing here is that essentially out of the box, we have parallelization. So a quick anatomy of a Horde job running in the cloud is that the Horde dashboard is what we were just looking at. That's the website overview. And we can run a job there. Job dialog is set by the parameters of that particular job that you're running. So build, cook, project is the standard, all singing, all dancing, compile everything, cook everything, deploy everything. It's going to send a job request to the Horde controller, which is the server. And the Horde controller is going to parse that job, and it's going to parcel it out to a bunch of Horde agents. And we have elected to parallelize by target, which makes things quite conceptually straightforward. And one of the reasons we can do that is because steps that are for Xbox are completely irrelevant to PlayStation 5. So it's a really good entry point for parallelization. So what's good about Horde? Why do we think that we want to move to it? It speaks Unreal Engine. So we're the Unreal ecosystem team. We want to focus on Unreal Engine related stuff. We don't necessarily want to go out of our way to learn new stuff that's only tangentially relevant. Horde runs build graph natively. Essentially, it's doing very little on top of just running a build graph script, which is exactly what you run on your local machine when you want to chain together a few steps. The code base is contained. This is a bit of a subtle point, but it's a pretty powerful impact. If we download the source version of Unreal Engine 5.4.1, that also has the source code for Horde version 5.4.1. We've got a guaranteed compatibility there. We've got support from Epic, and it's all related to the stuff that we're already touching. It also means that Horde uses the shared libraries that are available in Unreal Engine. So if we find an issue, we can go post on UDN, or if we find an optimization that we think is better, we can also add that into the code ourselves and then maybe contribute it back. Built-in telemetry is a bit of an unsung hero here, but that graph that I showed you before where we could see all of the timing for all of the different parallelization steps means that we can monitor without much extra effort all of the stages for our different jobs and maybe find out how we could optimize them to be even better. Horde is opinionated in its integrations, and I think that's a very Unreal Engine thing in general, but it's really good. It means that we don't have to manage a Perforce library of our own making in order to check out workspaces, in order to do complex source control integrations. We can rely on Epic's engineering knowledge for that, and it also strongly integrates with Slack. So if you submit a change list that's not a good one, Horde will ping you directly on Slack, and it will tell you to go fix the build. This is a double-edged sword, of course. Horde only works on Perforce. So unfortunately, if you're not currently using Perforce, Horde is not for you at this time. And as I keep going on and on and on about it, parallelization is dynamic in the sense that it's based on the build graph that you're running. In the example before, where I showed that we were running parallel for different targets, we don't have to change the entire code of the build job if we decide that Android is no longer a target we want to build for. By simply changing the configuration, which is as code, it means the parallelization is automatically computed by build graph and by Horde. So we're almost already optimized as much as we can be, as long as we're not doing anything too silly. Error handling is another related to Slack. Horde will parse the log for you, find errors, and associate them with issues. And those issues remain in a database, and they will persist until they're fixed. So if you want to, you can look at the health of your overall system by going through the issues and finding what those issues are and determining whether or not they're high priority, low priority, things like that. Yeah, tagging culprits is great. So that's a bit of an overview of Horde and where we were. So we're in a bit of a sad build state. We knew what we wanted. We thought that Horde could solve it for us, and we're kind of already got a bit of a crush on Horde before we've even implemented it. So now I'm going to jump ahead and give you the sort of outcome. So a really big highlight for the success of the implementation of Horde is for 2xKO. So this is our tag team fighter game, which was announced this year and is still in development. But we're starting to show it off, and you can find a bunch of videos online showing the awesomeness of the game. We're really excited about it. I'm doing a lot of work for it at the moment. It's a lot of fun. And 2xKO will be shipping with Horde as its primary CI system. So we've implemented it already. And here's the major result. The previous build system, builds took over 5 hours. With Horde, 35 minutes for a build, end-to-end, all targets. We've got at least 24 builds a day, because at the minimum, we can kick off a build once an hour. We can kick them off faster, but we only need to kick off builds when code changes actually go in. If there's a lull overnight, we don't even need to kick off a build, because we've already done one the hour before and nothing's changed. And like I mentioned, we've got essentially unlimited telemetry stored by Horde, because it is essentially just keeping it all and putting it into cloud storage. The massive improvement in build time is not really a surprise, though, if you dig into it. I mean, it looks great on this slide, but really what we were doing before was a completely serial build because parallelization was hard. But with Horde and build graph, it's really easy to access that parallelization and just get the benefits for it out of the box. So how did we get here? And kind of a spoiler again, it's infrastructure as code and configuration as code. That's it, that's me, that's who I am. Core SDK provides us, Horde infrastructure setup is non-trivial. There is quite a bit of effort that goes into setting up a Horde. And in this example, Vi on a game team is asking for Horde setup because their project is getting serious about what they're doing and they need some CI. Heimerdinger, who's a member of our team obviously, has already prepared these modules encapsulated in a way that means that we can deploy them with some ease. This is non-trivial still. We've wrapped Horde into 2 components, which is quite a few Terraform modules which provide us with default implementations that gives us sensible stuff that we can set up and then extend. So on the left, the Horde, not Horde agents, is the shared resources for the project, for the CI system. So that will be a Kubernetes deployment for Horde itself, the server and the dashboard. We've got a number of file shares, including S3 buckets and databases, which Horde uses to keep track of telemetry and keep track of its agents and what the different job steps have been completed or not, and run the program. We've got identity integration as well, so that users can be assigned to a project and have the right level of access for Horde. We don't want everyone to have access to the build system. It's pretty dangerous there, and so we want the right people to have the right access, and likewise we only want certain people to be admins of the Horde system as well. This is how we also configure our shared DDCs, because we're not yet using Cloud DDC. So we have a number of network storages and things like that to enable builds to be as fast as possible, making use of all of the Unreal caches. The Horde agents themselves is a relatively straightforward deployment. Here we're largely just creating servers, and we're creating servers with different pools so that they can be assigned to different types of tasks. When we set up a build, we generally start with a utility agent or a small agent which is going to parse the build graph and then determine what the rest of the build looks like. That's quite a lightweight task, so we don't need an agent that's suitable for compilation to get into that. So we can provide agents of different flavors so that the Horde system can utilize them as best possible and parcel out those jobs to the right agent for the task. I included 2 version numbers here as well because there's something that, that I think is pretty important. Oh, my line spacing's gone wrong. But the Horde agent here is a version 2.7.5, but the Horde other deployment is version 1.0.3. The key thing there is that because we've modularized this deployment, we can iterate on these things independently of one another, and we don't have to redeploy the world if we just want to update some agents, or if we want to make a tweak to the Horde deployment, we can do that separately. So now that Vi's got the infrastructure set up to run CI jobs, how do we distribute the jobs themselves? They're independent. So Brom is setting up the Poro Fighter 2000 project, and that starts with the core SDK deployment. So in a sort of schematic view, we end up with 2 parallel folder structures, which is what the game looks like. We have the standard U project with Poro Fighter 2000, where all the game-specific stuff, gameplay logic, and all of that, all the levels and all that good stuff lives. But alongside that, we have Core SDK as well. And within Core SDK, there's a build folder, which contains our generic build graph jobs and our Horde configuration. What we've done here is that's not a word. Made generic the scripts so that any project can make use of shared defaults just by switching on the name of the project. This means that our team in Unico can spend our iteration cycles really optimizing specific components for a build job, and then every project team that's making use of Core SDK can take that good optimization in the next time they take a Core SDK update. It allows our gameplay developers to focus on gameplay stuff and allows our build engineers to get into the nuts and bolts of things. But it doesn't stop a different type of expert coming up with their own automation tasks and contributing them back. The project itself has a few hooks in there for overrides, if they want to, for the configuration. A typical example of this is for the targets for the project to be built. If you're focusing on a mobile game, you might not care about Xbox. Likewise, if you're focusing on an Xbox exclusive title, you probably don't care about Android. So by setting up some properties or some low-code configuration, we can change that so that your build really only focuses on the things that you care about. So, going back to the recipe for success that I sort of talked about earlier. No ClickOps. We're using configuration code as infrastructure as code, which we always have been doing. That's all stored in our version control. We're integrating with our existing tools. We're using Perforce already, and now we're using Perforce even better. We're overcoming our existing challenges. We've got parallelization much more easily accessible. We've decoupled the build system from the build jobs because we're just natively running build graph. And we've got Core SDK, which allows us to ship some sensible defaults that are easy and accessible for game teams and are available to override when the game team has scaled to the point that they care about them. So what was the kind of outcome of changing to Horde? And this is sort of less the functional technical components, but sort of emergent, exciting stuff that I think is really awesome. So we've opened up the build space. Project teams care about build now because they can make a tangible difference to build if they have the time to think about it. Before, they were limited by 4 to 6 hours of build, which meant that they didn't care about it. But now, if they want to add in a small utility job or something that they want to automate themselves, they want to generate light bakes, HLODs, localization, they can do those things themselves with a low barrier to entry without worrying about how the build system works. We can support many teams much more easily now because we ship our build jobs with Core SDK. Our sensible defaults mean that if, as I mentioned, if someone else spends the time working on a job, the next game team will also get that benefit. And yeah, as I mentioned, we can contribute those things back to Core SDK. So if a game team has an awesome enhancement, that then becomes the default for everybody. Sort of anecdotal thing that I experienced recently was that we have a sound designer who is an expert in Wise tooling. And he approached me and he was like, hey, can we get some automation set up for generating some Wise stuff? And I thought to myself, excellent. I hadn't had a chance to look into this yet. I'm really interested in sound in a general way. I'm really busy right now, but here's a starter. Have a look at this code. Here's some defaults. Here's some examples from Unreal Engine source itself. Let me know what you think, and maybe next week we can get into this. And so he came back next week, and he'd done it all. I didn't get a chance to work on any of the Wise stuff at all, which I had hoped for because it was easy enough barrier to entry that he could just work out all those jobs himself. And as a sound expert, he's definitely not a build engineer, but had enough good examples and good entry points to get that done himself. We have made some specific Riot-specific customizations along the way to enable the things that I've been talking about. We are able to do this because the source code for Horde is shipped in Unreal Engine. We do this with a hesitancy, though, because any changes that we make mean that we have to maintain those long term, but there was a few things that we thought we really needed to add on top of. So Horde will parse the logs of build jobs to find errors and things like that, and provides a way of having ignores. If you've got that stubborn warning that doesn't seem to go away ever, that you feel You just need to ignore it. We don't need to worry about that now. We'll get back to it later. That's great. That's already out of the box in Horde. But we felt that we needed banned patterns. If you ever see a line in this log, that means something's horribly gone wrong, and we just abort immediately. So you have the ability to add in regex patterns to ensure that. We added a JSON tokenizer, and this is where the configuration of code has started to become even more accessible for game teams and allow us to just configure things off a single parameter like a game name. It means that as long as we follow a standard folder path or file path for all of our game developer environments and CI systems, we can separate the configuration just by a single JSON tokenized name. It's a bit of a double-edged sword though, because if you start getting into sort of nested JSON tokens, you can get into like a horrible world of, is this a significant piece of white space or things like that? So we've kind of got this set up as sparingly as possible for just the defaults. And then there are a few miscellaneous tweaks which have come about because of the Riot-specific cloud environment that we find ourselves in. We deploy a few instances of Horde, and what we found at one point was that neighboring deployments of Horde were turning off each other's agents based on how much work one deployment was doing and the other. So we had to we had to upgrade a couple of the ways that Horde interacts with the cloud and does its agent management to just make it that little bit safer. Actually, I think it was turning stuff on that should be off. And I was like, why is this agent up still? Like, go to sleep. Yeah, so I think for some of these customizations, I will hope that we get a chance to chat to Epic and maybe upstream them back ourselves, but not had an opportunity to yet. So, going back to our big result here, maybe now looking at those comparisons, you can sort of see how we got from 5 hours to 35 minutes. Yes, parallelization is a big point, but we did quite a lot of other stuff to get there as well. And the 2xKO team are pretty happy with that. So, what's next? Things have been pretty good, but we have not run out of challenges. We have sort of 3 core issues that I think that are on the slate to be fixed this year, I think. Operations is still hard for the CI system. Getting observability on the entire system is a challenge. Observability in general is challenging. What I mean by that is, do we have the telemetry to make sure that we know when our agents are online or offline? Should they be online or offline? Are we being efficient with our usage of resources? Every minute a server is running in the cloud is costing us real dollars. And how do we know if something's gone terribly, terribly wrong and it's Saturday night and we need to be online fixing problems? We've reached a really good situation, which is also a terrible problem with our build graph, which is that now people are really keen to contribute back to it. It's become a bit of a spaghetti mess of if statements, code flows, and a few choices that we had made early on have now become a bit of a bottleneck. In Epic's examples for their build graph scripts tend to prefer monolithic scripts, which means your build cook project for all of your targets is about 1,000 lines of XML. I'm not a computer, I can't read that. And we're at the point now where all of our experts are starting to contribute things back, and those lines of code are just getting bigger and bigger and bigger. So we're due for a refactor. And we need to sit down, scratch our heads, and think about what does this look like in a way that's maintainable for an ecosystem where we've got very smart people who want to help out. Probably going to be some new folder, subfolders per target. Not really sure. There's a lot of different ways to slice it, but I think that, yeah, it's going to be a good opportunity space. And the infrastructure deployments themselves are still pretty hard. We need infrastructure, AWS-specific knowledge to do that. Not anyone can do it. And when things go wrong there, you still need to call up the people with the right experience to debug your problems and get yourself sorted out. So we're not quite as easy defaults as we would like to be. Yeah. So hopefully that's a bit of an understanding of what we're thinking about when we're talking about CI/CD, and our recipe for success is hopefully some thoughts and thought processes which help us make decisions to enable us to support many different game teams. Yeah, do you have any questions about any of that? Well, lots. Yeah, thanks.